Let's look at tutorial question number 3. So state the Faraday first law, we will not discuss. We directly go to the question B. Calculate the mass of lead deposited at the cathode. So from here we have some idea here. Lead, cathode. Okay, but for sure again, actually before we go to question B, we have to go through the question, main question. Electric current 3 ampere pass through and electrolysis of molten. So again, once we look at the term molten, we know that the physical state is the liquid. Lead to bromide for 30 minutes by using inert electrode. So then we know that the ion present in the electrolyte is Pb2 plus and Br negative. So they already mentioned here is cathode. So we can know that, write the half equation is Pb2 plus liquid gain 2 electrons and produce Pb solid. So here you will have 1 mark. Okay, next one we have the ampere and we have the times. It can help us to determine the Q. So Q equal to IT equal to 3 time is 30 minutes. But here we must make it into the unit of second. So we're going to multiply by 60. So press the calculator, you will get the answer 5400 column. Okay, then now, according to equation, two more electron going to produce, two more electron need 2 Faraday, and then we're going to produce 1 more of lead. Okay, so in this case, we have 5400 column. So when you do the mathematics, when you convert it to Faraday, you will notice the Faraday is 0 0.596 Faraday by dividing with 96500. So then you will place this, do the comparison, 0.05596 Faraday will going to equal to, press the calculator, you will get the value here is 0.028 more. But then the question is asked us to looking for the mass of the lead. So when we want to know the mass of the lead, as usual, number of mole multiplied with the molar mass. So number of mass of lead will equal to number of lead 0.028 and then multiply with the molar mass 207. Press the calculator, the final answer is 5.796 gram. So here roughly we will have looking at the mark. So Q equal to IT, you will get this 5400 column and then convert to Faraday. Do the comparison and then get the number of mole, multiply with the molar mass, you will get the mass. So basically step 1, step 2, step 3, and then here we consider we have step 3 supposedly is here. Okay, basically is you convert to Faraday and then you do the comparison and then you can find the mass of the lead produced. Continue with tutorial question number 4, an aqueous solution. So from here we can see the aqueous solution. So later we know that the physical state that we can use is aqueous. Of platinum salt is electrolyzed using a current 5 ampere, and then after 2 hours 18.18 gram of platinum is formed at the cathode. Calculate the charge on the platinum ion in this solution. And then you are given that the molar mass of platinum is 195. So from here, as usual, we are going to write down the half equation first. Platinum, because we don't know what is the charge, so that's why we're going to put N plus, and then the physical set is aqueous. Again, because it's at the cathode, so gain electron, and gain N more of electron, because we don't know how much is the charge of the platinum ion, and then produce platinum, which is in the solid form. Okay, next we have the information Q. IT, Q equal to IT, I is 5, T 2 hours times 60 minutes, and then time if 60, consider convert to second, which will equal to 36000 column. Convert to Faraday is 0.373 Faraday. So remark over here, from column to Faraday, going to divide by 96500. Okay, so after we get this, then from here, with the mass and then the molar mass given, we will able to determine the number of mole of platinum form. Number of mole of platinum form equal to 18.18 divided by 195, which is equal to 0.0932 mole. Okay, then now here we're going to do the comparison. If 0.373 Faraday is used, we will able to produce 0.0932 mole of platinum. So now you want to know 1 mole of platinum need how many Faraday? So we're going to use crossover multiplication. Then end up we will get the Faraday is at the 4. So if 4 Faraday means that we need 4 more of electron. Therefore, the charge of platinum ion is 4 plus. Okay, why we know it's positively charged? Maybe some of you will know why we know it's positively charged, because the reaction is happen at the cathode, and then cathode undergo reduction, so cation ion attracted to cathode. Or the other way, maybe we can look at, because platinum considered as the metal. So metal, when they form ion, they will be always in cation ion. Tutorial question number 5. A metal X form a chloride with the formula XCl3. So from here, we know that the charge for the X is X3 plus. And then here we can see the word molten, so will be liquid, was electrolyzed by passing an electric current 3.8 ampere for 16 minutes. The amount of X deposited at the cathode was 0.347 gram. So as usual, step number 1, we always write the half equation. X3 plus liquid plus 3 electron going to produce X. Then next we calculate the Q equal to IT 3.88 multiplied by 16 minutes multiplied with 60, which is equal to 3724.8 column. So such much of the column basically is equal to 0.0386 Faraday. Again, from column to Faraday, going to divide by 96500. Then next from here, again, we are going to do the comparison. Okay, basically we know that 3 more of the Faraday, 3 Faraday, based on here, we know 3 Faraday going to produce 1 more of X. So now we only have 0.0386 Faraday. So how many more of X basically will be formed? So the question mark will equal to 0.01287 more. How to get this? Basically is use crossover multiplication. So then from here we know that 0.01287 more is equal to 0.347 gram. But we need to find out the relative atomic mass. So that's why we want to know the mass for 1 mole. So again, we're going to do the comparison. 0.01287 mole basically is equal to 0.347 gram. So then now, if you want to form 1 mole of X, so how many gram? So use crossover multiplication. The mass will be around at 26.96, or basically is 27 gram. So when this is the mass, to remember that the question is asked for relative atomic mass. So you have to rewrite again. Relative atomic mass, okay, I use the short form, relative atomic mass of X is 27, because relative always have no unit. Continue with tutorial question number 6. Determine the Avogadro's number, means that the Avogadro constant. If 12.05 silver deposited at the cathode, when 4 ampere is passed through 1 mole per decimeter cube of silver nitrate for 45 minutes, given that the relative atomic mass for silver is 108, the charge on the electron is 1.6 exponent negative 9 coulomb. So as usual, we will going to write the half equation. Silver ion, the physical state is aqueous, because here we can see the word solution. And then get 1 mole of electron going to produce 1 mole of silver solid. Then next, we're going to determine the Q equal to IT. I is 4 ampere multiplied with 45 minutes and then convert to second, which will equal to 10800 coulomb. So from here, from the question, we know that if 10800 coulomb is supplied, 12.05 gram of silver will be produced. So if we want to know 1 mole of silver produced, need how much of the coulomb? So we place 108 because the atomic mass of silver is 108. So press the calculator, we notice that the coulomb needed is 96800 coulomb. Then if we want to, this one is referred to 1 mole of electron basically. So when we want to know the charge on the electron, so we use the Avogadro constant, multiply with the charge of on the electron, 1.6 exponent negative 19 coulomb, which will equal to 96800 coulomb. So the Avogadro constant will equal to 96800 divided by 1.6 exponent negative 19, and up the value is 6.05 exponent 23. So this is the Avogadro constant. And then as we know, the theory value is 6.032 exponent 10 to the power of 3. So we roughly have the idea that this is theory. The value that we calculate is almost near there, so should be no problem. Okay, continue with tutorial question 7. A student wants to fill a balloon with hydrogen gas. How long a current of 12 ampere must be used in the electrolysis of water to fill the balloon with the volume 10 liter, pressure 0.924 atm and 22 degrees Celsius. So from here we know that electrolysis of water produce hydrogen. Basically, reaction here is referred to as cathode. So like normal, usually we are going to write the half equation of the at cathode. Water's discharge at the cathode going to produce hydrogen gas balanced by adding OH negative. So we'll put 2 and then balance hydrogen and oxygen, gain 2 more of electrons. So here is aqueous. Okay, then next, normally after we write the half equation, we're going to calculate Q equal to IT. But this time, how long is referred to the time, means that the question asks us calculate the time and then the electric current is 12 ampere we have, but then without the time we are unable to calculate the Q. So means that we are going to ignore this part first because one formula have 2 unknown. Okay, then next we try to look at what are the information else we have. 10 liter, 0.924 atm, 22 degrees Celsius. So I have volume, pressure, temperature, and also when we look at here is the gas, so we will think of the PV equal to nRT. So pressure 0.924, volume 10 liter, number of mole we have no idea yet. In this case we are going to use 0.08206. Temperature must be in the unit of Kelvin. So yes, very good. There is only one unknown. So this number of mole basically is referred to the hydrogen gas produced. So press the calculator, you will get 0.3817 mole. Okay, so from there we know more of hydrogen gas lah. So from the half equation, we already have the idea if 1 mole of hydrogen gas produced, we're going to need 2 more of electron. So now we only have going to produce 0.3817 mole of hydrogen gas. So we need to find out how many more of electron is needed. Okay, so when we times 2, so will be equal to 0.3817 times 2 will equal to 0.7634 more of electron. Okay, then now here we know that 0.3 more of electron, when we convert it to the column, 1 Faraday means 1 more of electron. So if now we have 0.7634 Faraday, we want to convert to column, so it's going to multiply with 96500, which is 73668.1 column. So Q equal to IP 73668.1 equal to I12. T is the time which we need to find out now here. when we press the calculator, going to divide by 12, so the time is 6139 seconds. So here, because of the question just mentioned how long, so you can keep the unit in second, or you either also can convert them to minutes or even to the hour also, no problem. So I think for the tutorial question, subjective part, we already finished here. So in the next video, we are going to discuss the calculation on the electrolysis in next video. So see you in the next video again. Bye.